This video is about line coding schemes. So we have various line coding schemes that is available. So first we will see what line coding is. Line coding is the process of converting digital data to digital signals. So data in the form of text, numbers, graphical images, audio or video are stored in the computer memory as sequence of bits. Line coding converts a sequence of bits to a digital signal. At the center, digital data are encoded into a digital signal. At the receiver, the data are recreated by decoding the digital signal. So this is how the encoding and decoding is. So digital data here from the center will be encoded and will be sent to the receiver, and it will be again decoded and will be taken. Now coming to line coding schemes. There are various schemes available in line coding, and we can roughly divide into 5 categories. One is unipolar, polar, bipolar, multi-level, multi-transition. So we'll see the first 3 now, and multi-level and multi-transition are the combined higher level version of unipolar, polar and bipolar. So that we will see further in the class. Now coming to unipolar. In a unipolar scheme, all the signal levels are on one side of the time axis. An example is non-return to 0. Here, positive voltage defines the bit 1 and 0 voltage defines the bit 0. It is called non-return to 0 because the signal does not return to 0 at the middle of the bit. Coming to polar schemes, the voltages are on both sides of the time axis. So non-return to 0, in polar non-return to 0 encoding, we use 2 levels of voltage. Here again we have 2 versions, NR is at L and I. So both have an average signal rate of N by 2. Now coming to NR is at L, the level of voltage determines the value of the bit. Whereas NR is at I, the change or lack of change in the level of voltage determines the value of the bit. If there is no change, the bit is 0. If there is change, the bit is 1. That is what is given here. If there is no change, then the bit is 0. See here, the bit is 0. Whereas if there is a change, the bit is 1. See, it was at level 1 and there is a change. Because it is 1, then it will continue to be the same if it is 0. Then again we got a 1. So this is 1, so level change. Again another 1, so level change. Again another 1, level change. And level will remain the same if it is 0. See. Whereas in biphase, we have Manchester and differential Manchester, where in Manchester encoding, the duration of bit is divided into 2 halves. The voltage remains at one level during the first halves and moves to the other level in the second half. The transition in the middle of the bit provides synchronization. In differential Manchester, it combines return to 0 and non-return to 0 I. There is always a transition at the middle of a bit, but the bit values are determined at the beginning of the bit. If the next bit is 0, then there is a transition. If the next bit is 1, there is no transition. The minimum bandwidth for Manchester and differential Manchester is 2 times that of NRZ. Coming to bipolar schemes. In bipolar encoding, there are 3 voltage levels, positive, negative and 0. That is why it is called bipolar. Then voltage level of one data element is at 0, while voltage level for the other element alternates between positive and negative. So this is all about the various basic polar encoding. Thank you.